quantities are in golden ratio if the ratio is same as the ratio of the sum to the larger of the two quantities. This means that if there are two quantities A and B and A is larger than B, then A by B is equal to A plus B by A, which is equal to 1.61A, which is a mathematically irrational number. One very famous piece known as the Mona Lisa, painted by Leonardo da Vinci, is drawn according to the golden ratio. If we divide that rectangle with a line drawn across our eyes, we get another golden rectangle. In the painting Last Supper, various design and architectural features show very clear golden ratios. Some believe that even the positions of the disciples around the table were placed in divine proportions to Jesus. There are various instances of golden ratio being used in Greek architecture and Egyptian pyramids also.
Quilting, knitting, etc. use fractions in every part of the design process. Secondly, shapes and curves are used to create patterns, and symmetry is used to align the patterns. Maths is used to measure sample garments for fitting, as well as to keep the sizes consistent. Geometry is needed when mapping 2D patterns that has to be designed to fit a 3D body. Angles, parallel lines are also used for design.
The minaret's weight, angles, and sizes were decided and constructed with the help of mathematical calculations. The equal distance of windows and doors from one another, the formation of the minarets, the proportions of the domes to the archways are astoundingly symmetrical. The mausoleum and its associated structures were designed around the principles of reflection and repetition. The dome itself is essentially a cube with chamfered corners to give it an octagonal cross-section. Reflection symmetries characterize the pattern of paving stones around the Taj Mahal.
Mathematical sculptures are those sculptures for which the use of mathematics becomes essential in their conception, design, development, or execution. Some examples of mathematical sculptures are polyhedral sculptures, non-oriented sculpture, quadrics, Mobius strip, topological structures, sculptures with symmetries, and algebraic sculptures. Algebraic sculptures include ruled surface, revolution surface, and minimal surface.
Did you know that the Pythagoras theorem is used extensively in designing and building structures, especially roofs? For example, gable roofs are made by placing two right triangles together. The span is the length from the outside wall to the outside wall of the building. If you have noticed, carpenters do not refer to the angle of the roof as 30° or 60°, but prefers to use it as the pitch of the roof. The pitch is the ratio from the vertical to horizontal measurements. Gable is a triangle formed by a sloping roof. A building may be a front gable or a side gable. When two roofs intersect, a valley rafter is formed where the length is equal to pitch 1 by pitch 2.
Fractal is a type of mathematical shape that is infinitely complex. In other words, fractals are a visual expression of a repeating pattern that starts out simple and gets progressively more complex. The most commonly shown fractal is called the Mandelbrot set, named after the mathematician Benoit Mandelbrot, who coined the term fractal. Another example is the snowflake curve by Hersch von Koch. It is a mathematical figure with 6-fold symmetry like a natural snowflake.
Zoomed in on this picture, you could find thousands of interconnected eclipses. This was created by the artist Hamid Naderi Agane. To produce images like this, the artist uses programs that instruct his computer how to implement his formulas, which often entail trigonometric functions such as sine and cos, but not always. He can produce thousands of shapes by altering just a few parameters in a single formula.
Very simply, spiralaterals are spiral-structured designs based on a repeated series of commands using their length and an angle. Creating spiralaterals also involves graphic and patterning, so that there's a whole host of awesome math and art integration going on.
In order to be synchronized with other dances and keep time with music, dancers must constantly be counting steps. Dancers form angles, lines, and simple shapes with their arms and legs. These shapes include circles, triangles, and more. In order to make it more appealing and make it possible for all dancers to be seen, we use different types of geometrical formations such as parallel lines, circles, squares, and pyramids. A dance displays patterns of symmetry such as reflection, rotation, translation, and glide.
Do you know that mathematics can be used to generate optical illusions? This great optical illusion was created by placing hexagons of nearly same size in a particular pattern, and this great optical illusion was created by placing circles of various sizes in a particular pattern.
Did you know that math had many uses apart from addition, subtraction, multiplication, and division? Maths can be used in various kinds of art such as curves of pursuit, Celtic knotwork, mazes and labyrinths, and to construct a snowflake.